My name is Etienne Bernard.
My name is Timothée Verdier.
And we're going to present a workshop. The title is End-to-End Machine Learning Project. So the idea is to walk people through all the classic steps in a machine learning project, and not just the training part, but also the data wrangling part or the deployment of the model. It's called End-to-End Machine Learning Project. The idea is not just to talk about the small part that is about training, that is actually usually a few lines of code, it's really not so big, but also speak about what comes before, what comes after. So before it would be in terms of data handling, even data storing, and after in terms of deployment, these type of things, and also give some technical solution, even for training. For example, what can you do if you want to train on the cloud and not on your machine? And so we'll provide one solution for that. And what can you do if you want to deploy your machine learning model, let's say, on a device? So we won't explain that in detail, but at least we give you an idea of what to do in order to do that. So that's really the idea, to see all the components of the machine learning project. And actually, all right. So actually, that's a part we're going to talk about. By the way, is it big enough? Maybe I put 150. Although it's a small room, so that's good. Is that big enough? 150? Yeah. So yeah, talking about the data wrangling part, this is the part how to extract the data, how to clean the data, how to augment the data, how to store the data. Then there's often a data understanding part. That's usually when we start playing with the data, plotting histograms, things like that, to get a feel of what this data is, which is very useful to avoid some mistakes. Sometimes there's some crazy thing in the data, and we can spot it with this sort of simple analysis. Then we'll talk about the modeling, okay, the classic machine learning part. We won't spend too much time on that because there's been many workshops that are exclusively about this part, including so many neural network workshops, for example. But still, we'll talk about how to do that on the cloud, for example. And then how to use the model that has been created and how to deploy it for the application that you had in mind. Okay, so data wrangling. So this is probably often the longest part, by the way. So it involves importing the data, cleaning, extending it. So for example, importing, so for that, there's a very simple function, import, okay? So you can import a spreadsheet, and actually, let's see it. All right, so that would be the way to go. By the way, import, you can also import some database format with import as well. So that's really the main tool. There's one tool that is called Semantic Import. There's more recent by import, although it's already maybe 3 years old now. And the idea of this function is also to understand the data that is imported. For example, it's the same spreadsheet, but this time it understood that date was a date, and that city was a city, and sales was just a numeric number. And it interpreted the date as a date object. This is a date object. And it interpreted cities as entities, okay? And this can be useful to, for example, from date, you can extract extra features. You can extract, was it a Sunday or not, which might be useful, be a useful feature. Or the city, you can extract, let's say, the population, which might be useful to do the prediction task that you want. By the way, one thing that, no, I guess I will talk about it after. Okay. Okay, so that's one way to get data, usually the easiest. Spreadsheet, pretty easy to get the data. But sometimes you might want to have some more off-road way, such as scraping from the web. It's pretty classic that you have data that is on some website, on some somewhat structured way, and you want to extract this. And this is a very hacky world. So we won't go into a full example, but just to give you a rough idea of usually how it goes into downloading the URL locally first. Okay, and there's a function called URL download, URL download submit that does that asynchronously. So that's a two function. Then once you have downloaded the URL, you can import them offline. So you can import the hyperlinks, by the way, which is useful if you want to navigate in the website to figure out other page to other URL to import. So that's how you can create your little bots that explore the web. And then the best thing, I believe, is to import that as an XML object because it still contains all the information about the page and scrape the data from the XML object. And for that, typically, two techniques is to use position and part. Like let's say I wanna extract all the element. Should we go directly to the example, or maybe to be easier than speaking about it? Okay, so let's see. So here's an example problem that we have. Just to go to a web page in the Wolfram website. Okay, so this page. And the idea is, okay, we want to extract all the titles of this page, okay? All these things. And how can we do that? So the first thing, as I was saying, is to, okay, here's a URL with the URL header, which can be nice because you can just click and it goes on the URL. And okay, I mean, okay, for that case, it doesn't matter to import hyperlinks, but just I wanted to show you how to import the hyperlinks. Is that a valid file? Or URL, it is a URL. What is going on? Okay, for some reason, import doesn't work if it's an URL. That's weird. But okay, that's all the links, for example, in this page. So for the problem at hand, it's not useful, but just wanted to show that. If I remove the head, yeah. I mean, I think it goes back to the string, huh? Yeah. It's not normal. It should work with URL. That's weird. That's a bug. And okay, so now let's extract these titles. So we're going to download the URL into a file. Okay, so actually I could show what the file is. Okay, that's the file, and then we're going to import it as an XML object. And if you look underneath, so XML object is like this huge expression, okay, that represents the website. And you might say, well, that's crazy. We'll never manage to scrape anything from that. It's too complicated. And it's partially true, because sometimes it's pretty complicated. That's why it's a bit of a black art. But let's say we have, okay, Wolfram language reference. So that's the first one, let's say. Which one is, okay, what? And we can just do position in this expression. And we say, okay, Wolfram language represent is there. Then I can say, oh, where is Wolfram language homepage? And I can look. And as I was saying, it's very hacky. And I say, oh, look, there's only this that change. It's from a 4 to a 2. And then I say, oh, let's get something for the second line. And then I noticed, oh, there's a 2 and a 6 that only change. And then I figured that, oh, it's actually a grid. And I just need to put a range here and put that and get all the titles. Okay, so that's a very hacky way, but in practice it's useful because websites are always structured, and there's always a structure. And when you find the structure, then you can scrape things, and it's pretty convenient. So there's another way, which is using pattern matching, and this would be kind of, let's take this position, okay? Let's start from that position. So this should grab the title, and then we go back in the tree. So I guess something like this, And probably if you match everything in the XML object that has this, this pattern, you will grab the titles. But of course, you need to remove some specific things that are specific to this title. So of course, you have to remove this, maybe remove the item width, maybe remove the link, and so on. And then you do cases. And so you see here cases. I put a bit of blank to some places. And I also put something where the title is and output the title. And here you go. It's actually pretty robust, this one. So that's another case on how you can scrape things. Yeah?
Consider using Beautiful Soup at this point.
Beautiful?
Beautiful Soup?
I don't know what it is. Is it a tool, a software to do this? Oh, it's a Python library? Okay. No, I don't know it. I mean, I always used position and cases. I mean, I'm pretty used to the language, so it's pretty fast, but...
This is the example where you step out of Wolfram for a second, look at this thing, it is amazing, step back in.
Yeah. I mean, does it have pattern matching like that? Because this pattern matching thing is pretty powerful, and I think this is something that Wolfram language is pretty strong at.
The previous step where you're parsing code, parsing the website, that's what Beautiful Soup excels at.
Yeah.
So the amazing variety, you don't have to worry about how people build their website. It just does that part.
It's interesting. Yeah, I didn't look at it. Thanks. Okay, so let's not go too deeper on that. As I was saying, it's a bit of a black art, but it's very useful. So another part is about cleaning the data, about interpreting it, about including some extra features. So here you can use all the classic data manipulation function of the language, including, let's say, to remove bad example, select, replace, things like that. Interpreter, very useful to interpret. For example, if you know it's a date, you can use interpreter date to then interpret a date object and extract features. That's what I was talking about. You can interpret it as entities. Let's say we have cities. You can interpret the cities and then use entity value to extract some features. That's what we'll do in this example. So here, the idea is to import, but not with semantic import. Okay, that would be cheating in that case. Import the spreadsheets that I showed in the beginning. And the goal is to add the population of each city to the data set. Okay? So maybe we could do that together. So this is importing the data. Here I just remove the names of the columns. Okay, it's be a bit easier to handle. And in order to be fast in that case, I'm just grabbing all the cities. So here I select the second column. I delete duplicates, so I have all the cities. Yeah. Yes. Exactly. Data cleaning section. Yeah. Sorry. Yeah. I hope that you can. Yeah. You have these small things, right, to open. Okay. Otherwise, if you don't have this kind of things, you can go on the cell and double click. Okay. It's true. Yeah. We closed everything. I hope no one is stuck with something all. Okay, so here to be fast, so in that case there's not many cities, so actually we could do it by hand and look on Wikipedia or something. But in many cases you have many more things, and for that you can use interpreter city, okay, and this will interpret and return entities. And then from this entity you can use entity value or actually a shorter things like that. I can just say open bracket, population, close bracket. It will work as well. To grab the populations. Okay? And then I do association thread because I will do a kind of a replace, but I will do with association. It's a bit faster. And then I'm going to use this association. So you have to replace all the cities by their, well, not exactly replace, but to append I mean, at least to get a column of population, okay, with lookup, where is association, and this is the column in question. And I do quantity magnitude just to remove the quantity. So here I should have a list of population, and then I just append this column in the existing data set, and by just using append, by just doing a map thread. So each element I will append the corresponding population, a sort of zip type thing, and I just do data set to visualize again. And you see, we added the population of the city. And by the way, this is a really, this is really a strong part of the Wolfram language. Since you have access to this data, I think that's a huge added value for data science application. I mean, when I did some project in data science, I often use that to add some extra features, and so that's very useful. Okay, maybe Timothée will talk to you about data storage.
Yes. And right. So once you have done, it's
just one thing. If you have questions, don't hesitate to speak. Yeah?
Okay. Let me come back here.
I guess if you want to import it many times. For example, sometimes they have. I mean, it might be slow to download it each time you want to import, and also you can do that as a asynchronous task in the background. You can just have something that downloads everything overnight, and then you can work on importing the correct way and so on. Although if you always do XML object, I guess it's fine, but you might sometimes try to import in another way. So yeah.
And also, as you're like, this is the black art, and you are like trying things and methods to get away with what you want. You will have it locally in order to play with it, which is something that.
Otherwise, you will have to store the XML object in a file. But it's always nice to store that, then you can
Okay, so. So next is how do you, it's probably about how do you build on and scale once you like started this process of getting some data, and how do you link your data, how do you use this rich feature that of course comes from the Wolfram alpha knowledge if you have entities, but in your very specific field, you might want to do that for you and be able to link many data sets together. So at this point, you don't want to, do all this work to have a data set, play with this, and then put it in a random place on your hard disk, and 2 weeks after, well, maybe a bit longer, but to say, oh, maybe there was a connection between the work I did there, and you go back to your notebook, and it's a big mess because it was like the dark hard part. So once you get to this point of having this clean data, you might want to store it in an appropriate way and scale up with all the data you get, and this part is also something that will probably not evaluate on your laptop, because this is work in progress, and this is to give you a taste of what's coming and what we're working on.
Yes, this needs 11.3, right? So
yeah, and just let me just check.
Mongolic is a solution we use internally to store our data set.
Yeah.
Yes, this part is not supposed to work.
This part is not.
But if you wait 1 month on 11.3,
it's not supposed to work. But it's to give you an idea of how this will work and what's going on behind all this. So what you want to do is, once you have those data, is to organize them into a database in a way that you can actually query, link all those elements, and generate new data sets by actually like just grabbing the information you need. So so for that we have been people are working on this MongoLink connection in order to enable you to do that with a MongoDB system, which lets you query metadata from any type of data set you want to store. So once you have opened a connection, you can just link to a database that I just fed with an example, and the way it's organized is you have collections, which are, so one collection is something like what Etienne just gathered with a city, the ville. It's a data set with documents in the MongoDB language. That is one element with all the properties in the field you're interested in. And so, for instance, here we have this Titanic collection, which is which I can like get in touch with. This is all stored on the cloud. So this is not local in the computers. That's what you need the client and the collection. And this is the Titanic data set that I just that was just moved there by Megan. And once you have that, you can just create new data sets on the fly, saying, "Oh, I want those elements from the information I had. I want to link data set and generate the data set for my new purpose." And this is what we like an example of. Yeah. So if you have a collection, for instance, this will actually aggregate the element based on filtering and put in the organization you want. So for instance, here we're gonna group. So what the Titanic collection is a list of passengers, the class they were traveling, and whether they survived or not, their age, and things like that. So you can say, oh, I want to pick in this collection the information of all those passengers. I want to group them by sex and the class they were traveling, and I want to actually count the number of passengers and the average age I had. And so this link allows you to actually talk to the MongoDB system and generate the data set you're interested in from the information you already stored. And you can, of course, add new passenger information to your data set because you went on with some other scrapping data mangling. And so that's the idea, that once you have those data at hand, you might want to store them in an organized manner, and we are working in order to develop the tools and the link to do that very efficiently on modern technologies.
Okay. By the way, if you're interested in this MongoLink, which is really useful when you start to have a lot of data, if it's just a one-shot project with small data sets, who cares? But if this data set, as somebody was saying, that you're going to use again later, and you spend some effort doing it, it might be worth to put it in a nice database that is nicely queryable and so on. And if you have more questions about that, Megan is our data manager in our team, so she can tell you more about it and explain how it works. And yeah. Okay, so let's go to the data understanding parts. Okay, so now the data is in a nice database. Actually, I'm not going to use from database, but whatever. Let's imagine it is. And now what we want is to have a first feel about the data in order to avoid some bad mistakes that we can do. Like something. For example, we might not see that a variable meant missing. Classically, missing might be none in a data set. Sometimes it's something else. Let's say we don't see that. We miss that. Sorry. Then we might train, and then maybe we'll get super good results because, or maybe let's say the missing is the output, and we get super good result because it always predicts missing. Like this sort of thing. There's a huge variety of trouble we can run in, and this helps to avoid these problems. So let's import two data sets. So this is about a data set of football, soccer players, if you're American, football, if you're not American. And matches. So these actually things that I scraped from a website to do prediction on the World Cup 3 years ago. There's a blog post about that. So you can have a look, which is, by the way, an example of an end-to-end machine learning project, from scraping the data to, in the end, using the model to do prediction against betting odds to see if we can make money with this. So it's really you can have a look at that. So I downloaded the data set, and it's, by the way, yeah, it's pretty classic to also have data sets that are separated in data sets. And actually, one part is also how to merge data set into a final data set is ready for training, which I won't show here, but that's also a part of it. Okay, so of course, let's look at the length of the players data set. Okay, there's almost 80,000 players. That's the features. I just got all the values and did a new duplicate. Maybe I should have looked what it is. So this is actually an association players. So you have some keys. It's a big association, so I won't show everything, but it's kind of the index of the players. And then for each of them, you have another association. Okay. That is just an association of features. So you have the name of the player, his birth date, his position, number of international selection, things like that. And it's actually highly varying, the number of data that we have for a player. So, okay, that's typically what we want to do. So, okay, this is like a subset of data sets. And we can see some other subsets. Okay, that's a kind of a tiny, this one don't have many features. Or this one have more. This guy, we also have the weight and the height. I don't know how to say that one. Okay, we can do the same for the match. So, okay, so it's the same thing, right? And you have some features for each match, and such as the competition, the venue, the attendance, the dates, and so on and so on. Okay, so that's the data set. One important thing would be to look at missing data. So here, I use actually the data set language. So I transform this data set into a data set with a big D, okay, into the symbol data set. And then I do that, to transpose it. That's something that is really convenient with data sets. And then I can use a syntax to say, take all the columns and count the number of missing and divide by the player, and then sort by this thing. And here we go. So here it would give the fraction of missing features for each, of missing values for each feature. So apparently we have the name of all the players, basically. They always have number of selection, but we only have 25% of the player that we know their birth date, and only 20% that we know their position. Okay, so that's something good to have in mind. By the way, you can also do that without using a data set, just with classic Wolfram language function, if you're more used to it. Like in that case, it's a much nicer syntax, but I know even myself, I'm more used to use classic expressions dealing with associations, so I often don't use it. Yeah. Transpose is let's say, actually, oops, sorry. Let's go in data set. Let's go in data sets. Okay, yeah. For example, in this example, okay, let me put bigger. Okay, so here is data set. And you see that you have the column, 3 columns, A, B, C. If I transpose, it will be 3 rows, A, B, C. Okay? It transformed from the columns to row. So in that case, that's why these were columns and now they are row, name, selection, birth date, and so on. Okay, so we can do the same for the matches, and we see, okay, here there's no missing, and then it starts to be like the manager is not there always. If I go down, oops, I should have clicked that one. I shouldn't have clicked that one. I think we removed this thing in the next version. There's sometimes problems with this bar. Anyway. You can navigate with these ones. They're safer. This is a front-end thing. It's like how to display the this version doesn't like it. Okay. It's a front-end thing, so I think I don't know actually what this version is. It's your working on your machine? I don't know how to stop that. Okay, I can start telling you. Okay. So, oops, no. Okay, I can tell you a bit about what we do just after. It's we to look at the distribution of features. So if it's a numerical feature, okay, if it's a bunch of numbers, you might want to look at the histogram, okay? If it's categorical features, like let's say the position of the player, goalkeeper, defender, and so on, you might want to look at the bar chart or pie chart or something like that. So that's this different visualization to have an idea. For example, you might want to spot mistakes. Like you look at the distribution of I don't know, of weight in player, and suddenly you see a big pike at 2 tons, and obviously you know that's wrong, right? There's something wrong with the data, and this happens. Data get manipulated a lot, and there's some errors, and that's a bit of the role, of a data scientist is to have this human knowledge of okay, this is the height of someone. People cannot be 4 meters. That must be wrong, and I remove that. And that's the idea of doing all this part. Okay, let's continue like this. And so, for example, here I just do the histogram for all the numerical values. I also use dataset syntax. You don't have to. So here, if I click, but it's quite nice because it's if I click selection, I will see the histogram. So this is the number of selection for each player. Everything is right here, although histogram doesn't seem to be. Probably should put a plot range or to be sure to see everything. In that case, I didn't do it, but actually that's a bit dangerous. I should have done that. Okay, division of height, everything seems right here. Weight, everything seems right. Okay, I can do the same on the matches. I will look at the attendance. So attendance, okay, if I click there, seems okay. Score 1, so that's interesting. Like most of the match, the team won. This is the number of goals that the team won scored. Is about 1 or 2 goals, something like that, and this should be about the same. And this is just a categorical value, a categorical variable or nominal variable. This would show the continent in which the match took place. So apparently most of them are in Europe, Asia, and Africa. Okay, that's very classic Wolfram language. Use a Wolfram language and very useful. This is okay. This is a bit more advanced thing. Is that in this case we have a data set where you have many examples that are ordered in time. Okay, and one very important thing is to see the evolution of some variable in time. For example, here, just a random one, okay? Because it's interesting. Mean number of goals per match for each year. And we can see that in the past there were 4 goals per match, but nowadays there's maybe 2.5 goals per match. And it's important to realize that the data is not the same in the past as it is, at different time, different period. It's not the same data. It's important to know when you will test, because if you just randomly, what you want is to predict what's going to happen in the future. So if you just shuffle every match and then test on that, it will be a different statistic than if you just construct a test set that is at the end and a training set that is at the beginning, which is really the setting you want. You want to train on the past and predict the future. So that's an important thing to realize. But if you see that everything is flat, that date doesn't matter, then all right, let's shuffle, let's do training set, test set splits that are random. So in that case, there is an evolution. Okay, that's another fun thing. That's that's allow you to do some sort of baseline. This This gives you the percentage of matches that have been won when the team was at home, when the team was away, and when the team was in a neutral location. And you can see that when the team was at home, it's already 50%, like 1 match out of 2 at home are won. That's a really good baseline. You can always predict that the home team wins, except sometimes there's no home team because it's neutral. But if your model does less than 50% of accuracy, you might say, oh, there's a problem. There's a problem. Our naive baseline was better. So yeah, this sort of naive baseline are very, very useful. Okay, now let's go to the, 10 minutes already? It's 14 here. It's 14 on this one. Okay. Okay, let's accelerate a little bit then. Modeling parts, but that's good because there are many workshops about that, so we won't talk too much. Here I'm importing the data set that is kind of a gathering of the player and the match, but the gathering is a bit tricky, so I just give it as is. And because I construct extra features such as the Elo ratings of each team. So you have 30,000 example, and I'm going to cut it. So they are sorted by date. So I'm really going to cut it 25,000 and then the last 5,000 to test. Okay, that's a training and a test set, and with classify and predict, very easy. Just classify. Okay, so here we go. I run classify, and should start training. This is a bit of preprocessing. Then you should see a training panel that I will talk more about, by the way, in my talks. Oh, that's weird. There's a bug. What's happening? Things are cut. Huh. No, it might be because in presentation mode. Whoa, wow. Okay, yeah, it always works for me, always. Not this time. Okay, that's interesting. That's really, yeah. Let's restart, or even just the kernel. Yeah. That's really weird. Okay. In any case, that's not the most. That's not the goal of this talk to talk about the training. So I'm going to go pretty fast on that. So again. Did I just remove the? Oh, I removed the thing after classify and predict. Oh no. Okay, this is kind of working now. So you can see this training progress panel. We can see a learning curve. You can stop at any moment. Okay, let me just actually go back in time because I removed the next. Okay, but anyway, it's trained. And then you can use classifier measurements to measure how good the thing is on a test set. So apparently we got 56% of match right in that cases. And you can look things like accuracy, the confusion matrix that are useful to debug your model, and also debug data set, by the way, because then you can see, oh, that's really weird that this thing is misclassified as this thing. So let's look at it. And then you realize, oh, there was something wrong with the training set. It has been badly tagged. So analyzing the model sometimes makes you discover problems in the training set. Okay, so that's what it's for classify, and Timothée will talk about NetTrain.
Yeah.
Locally and on the cloud,
yeah,
which is an important part.
So
yeah.
Back to the future, as you may see. NetTrain. There we go. So let's move on to the simplest example possible, just to focus on how it works, right? So sign function, little bit of noise, network to predict that. Okay. So very simple network. Not what we are interested in this case. And locally is just, oh, train this network net on the train set with the validation sets and for 5 seconds. So let's go. And here you can see that the training goes on for 5 seconds, and we got to train nets. Okay, and we can show what it looks like on the test set and give it that things work. precision also, things like that. But what I want to give you an idea of is how it is if you want to do this on a powerful machine and remotely, and what we are preparing in terms of tool to do that. So we're going to an example of remote training on a cloud using the cloud computing of Amazon Web Service, known as Elastic Cloud Compute. Okay, so in order to do so, you should prepare your data to be transferred to the remote computer. So this is just like saving M file and the net, the pre-trained net on files. Okay, that's an interesting one. Yeah, no problem. I should have stop here. It's gonna be easier. Okay, so now we have a node. Yeah. No, I think it's good. So I put everything in this training folder here. You can see that you have the network, you have the train set and the validation set that I want to move to the machine. And I'm going to prepare a script for training, which is I want in the script to actually point to the file where they would be in the remote machine. So just like setting the file path based on the directory position, on the notebook position. And then I just import the net, import the training data, import the value, and just run net train. But this is a script that's going to run on the remote machine, right? So an interesting thing is I want to train on the GPU of the machine, because that's what makes sense in this case. And I will checkpoints. That is, because the machine might have some issue, I want to save at a given interval the value of the network, not to lose everything. And then I'm going to export the final network, that's an important point, as final.wnnet. Okay, so this is our script. And I'm going to put the script in the training directory, because I need the script on the remote machine too. And okay, this is just toy data, but you might want to actually compress your your data to move it to the remote computer. Okay, so now let's move to the Amazon console to give you a flavor of. So you need an account, whatever cloud you like. Okay, and now you can start a machine. In order to start a machine, you will need a machine configuration, which in Amazon is a machine image. So if you have, for instance, started a machine previously, installed Mathematica, you can save the configuration and launch machine from that. So that's what we have here. Let's take this guy and launch a machine with this configuration. We've got, we want the GPU. Let's take this one sorry. Let's take this GPU and move on. So as you can see, you have like plenty of configuration details that we're going to skip. You can tag your machine, saying that, for instance, I'm the owner of the machine, and that's it. And now we launch a machine, and it's going to say, oh, you need, in order to discuss with the machine, you need to authenticate through SSH key pair. So either you already have created one, either you created one now. So let's choose an existing one, and I have my key here, and I have to say that I do have my key on my local computer, and let's launch an instance. So this will launch the machine and make sure it's ready for. So here we go, it's pending, and the machine's going to warm up. Now here, okay. So directory set directory. Directory book. just to know where I'm working in other Wicked directory. Okay, so now I'm on the desktop, so this should work. Yes, so now I have my, so I just like make an archive and tar everything in a single file because you don't want to move like many files around. Okay, so I have the single file with all the training data and information to transfer to the machine. And now that we have launched the machine, we will connect to the machine and start the remote training. So first thing is that since this is the first time I connect to this machine, I have to like acknowledge it as a known host. So if I move back to the console, can I move back to the console? Yes. This machine, I just want to connect to it, and Amazon is saying, oh, if you have my key, you can just use this command here. Okay, so this should work. Let's try this. Okay, they have default username, and for it's a Linux machine, so the default will be Ubuntu here. Okay. Okay. Desktop. Let's move here, and let's do it. Yes. Okay. So here we are. We're actually talking to the machine on Amazon that was started like this, and we can know that it's in the known host. I don't need the terminal anymore, and I can just pass the command. So first thing, I want to move my training data to the machine. So just have to give the actual machine address. So this will go there. So, right, this is the machine address that was sent back by Amazon, and I want to move things there. Right, I assume it's done. Let's see. So yes, training.gz. It's there. Then what I want to do, I want to say like, oh, get the thing out of the archive, right? Sorry. Oh yeah, right. I hate this. It's yeah. Okay, I need to. Okay, so if I had to do things properly and change the host, this would like uncompress the archive and get everything settled. And then next time is to actually run my script. Okay, and okay, so once I've run my script, it's exactly like running something locally, but it happens on the other machine, right? And then what I have to do is just to move back the final net configuration on the machine, which has been like run on this instance, and that's it, right? So what we are actually doing, okay, that's
yeah. So this way of doing is a current way you can do right now, but what we are doing is trying to develop tools to make that easier. The first step is an AWS link that Timothee is just going to mention and talk about, and a future step would be to think directly in NetTrain, where you can have some data and say, upload this to EC2, and you have some sort of EC2 object, okay, and you can put that in NetTrain, and it would directly train on an Amazon machine. So hopefully we make that even easier, but wanted to show the true way to do it right now. Yeah.
Okay. So
we want, yes, that's what we want to do.
That's part of what we are like doing, what I'm doing currently, developing. So just to give you a view of what it might look like soon, if you just need to initiate the connection, and then you can use your client to list the running instance. So here I see that I have this running instance that I own on Amazon directly from Mathematica. I can just launch an instance with my default value, like this. This is like I just launch an instance with my default value. If I look inside, I will get the new instance I launch, which has different values than the one. I can tag this new instance saying that I'm the owner, which is like already working. So I now got the tag on the instance, and I can eventually terminate all those instances so the one that I listed here, up, directly there, right? And of course, you have stuff like in which you can bid for instances in order to get cheaper price, but you can get kicked out of the machine. And this is something for which you might say, oh, I want the prices of this type of instance for the last 1 day, and you just get those prices straight away from the link here. You can say, oh, so I'm gonna be like $0.4 because it's enough for the time I need to stay there. So that's what the AWS link and the near future is about.
All right, that's cool. So let's talk about usage and deployment. And as I was saying for the training, I want to stress that again, there's really 3 stages. Right now, you have to do everything with Amazon on the website, command lines. Then 11.3, you can already use AWS link. And then maybe 12, I don't know, directly with NetTrain. And yeah. Okay, now you have something trained, and how do you use it? How do you deploy it? So the simplest thing is to use locally. And for many applications, you might not want to deploy in the cloud or whatever, just use locally. And so for that, export your model. We created a language in 11.2, I think, that is called Wolfram Machine Learning Format, WMLF, where you can store classifier function, predictor function, also neural networks. Everything that is machine learning related, you can store it in this format. So just with exports, so now the classifier is exported, and we can import it with import and use it later. That's how you store it. On the cloud, like any other Wolfram language code, you can create a form function or an API function. Form function will create a small website for humans to enter things by hand, and API creates something that the machine can connect and give the input in order to run the program and get the output. So I will do that very, very quickly. Let's say, here we grab the, oh, but I quit. Okay, then let's just talk about it. Here we just grab the type from classifier information, and I will replace this type because the API need to know the type of the argument, okay? So numerical, in my case, it will be number, nominal, it will be string, and I can just do a form function, test the form function, deploy it with Cloud Deploy. And same thing for the API function. And okay, so that's really, like, this is really straightforward to deploy that on the cloud. And now, there's also ways to deploy on specific device only for neural networks. So I'll let Timothée speak about that.
Thank you. This is to show you what's where the Wolfram language neural network framework is in the world of the neural network system. So we are here, and you can currently you can currently export to MXNet, which is what we use in the backend to actually run the calculation. So you can have the MXNet code, which comes into 2 files, a JSON file and a param file, and then you're in the MXNet world. So anything MXNet can do, you can actually do it. So you have many exporters, which might work with several other classic lower level language. And from MXNet, there are 2 very interesting things to keep in mind, is that there is actually this ONNX language that is meant to be a way to actually move from one language to the other, and which we also plan to link. And if you want just to deploy, what you need is to compile actually to a specific architecture. And there is already from MXNet this path from this NNVM, that is a graph representation of your program, TVM, which is getting an intermediate representation from which you can compile to the whatever architecture and low-level compiler you want. So CUDA which is very classic for GPU, but classic computer, Raspberry Pi, everything is going to be integrated.
So this is already there. Since we
direction.
have the exporter to MXNet, then you can just compile from MXNet to whatever you want.
Yeah.
Okay, I think that's it. Thanks.
Sorry for the time.
Maybe there's some question. I don't know.
So AWS is actually kind of expensive compared to like DigitalOcean or Vultr. I don't know if they've got GPU instances. Are you targeting other cloud services?
I don't think we looked at many others because everybody used AWS. Also, we expect, I mean, we hope that AWS will soon have the Volta cards, which are blazingly fast to train neural networks. So they announced they will do it at some point. They didn't say when. And I don't think there will be much competition against that.